The agenda for today is pretty lightweight. So what I'm going to show you is like we'll start writing a very simple REST API that's going to call Google Translation Service to translate the text that we are passing to it. So it's going to be written in Golang. So we'll start from scratch, write a simple test case and simple server that's going to expose it, and then finally we take them, package them, and deploy them using a CI/CD workflow. And then we also see something touch upon GitOps. How many of you heard of GitOps here? So we'll do GitOps finally to do deployment onto a Kubernetes cluster. So this is going to be our agenda for day. I'll try to keep it as interactive as possible. Please stop me anywhere you need some questions, or else we can also park it at the last to take all the questions together, right? Great. So let's start with things. So let's go to the code, right? So let me go to my Visual Studio Code, open the command prompt. So let me go to. So this font is very small, or you can see it from behind. Let me go to my terminal font and make it a little bit bigger. Okay. Let me make this as well 25. Yeah. Is it clear from behind? Great. So I'm going to make a small directory and then traverse into that and then go more. How many of you know Golang here? Golang? Okay. So, but I'm not going to go any deep into Golang. It's going to be pretty simple, straightforward thing. Even if you know Java or any other programming language, it's going to be quite similar to that. So I'm going to start doing. This is a very. If you are very familiar with Java, then just like a Maven form archetype create kind of thing. So that's what I'm doing right now. I'm just going to do go mod init, and then initialize my repository, and then I'm going to go there into that right now. And this module file is like your form XML. I can just imagine like that. The very first thing I'm going to do is like I'm just going to go the way we used to code from a test.go, and then since that's going to be only one thing, I'm just going to use the main package where it's going to run from, and I'm going to write only one test kit like greeting. Okay, that's full the stuff for me, and then that's it. So what I'm going to do, I'm going to expect something on this text thing, right? As we told, like my service is going to basically do some kind of a greeting to the user using a specific language that you're going to send it to us. And this language, I'm going to use Google Translation API basically end of the day to call. And then why I chose the Google Translation API is because this is a very common thing we see at every place. But end of the day, any API that you call in Google, right, is always going to follow the same pattern, except that the parameters that you're going to pass is going to change, right? Other than that, the APIs are going to pretty much remain same, right? So what is going to return to me is a simple message, the translated message. That's what I'm going to expect from this. So my translation message, I'm going to use Google Translate. This exact thing I'm using from an API. So I'm just using from Tamil. So I'm going to translate that into Tamil and then say this one, right? That's what I'm going to use. So what do we need right now is greetings. So let's do the parallel coding here. So I'm just going to open up, split this right up here, and then I'm going to call another thing. It's also going to be on package main. I'm just going to call this as server.go, right? So and then I'm going to put a type here. This is just a simple struct. What this struct is going to have is going to take a name. And this name is going to be passed from a query string. I'll show you once I write a test case, you'll know what is getting passed. Query string that's going to take the same name argument. And when it gets serialized into JSON, that's going to serialize as name. Okay. I'm going to have a couple of more objects here. It's going to have lang that I'm going to use. This is typically the language in which I want to get it translated. And lastly, the message that I'm checking for here, the same message here. So it's going to be another string. It does not come through query string. So I'm just going to do this from this one. Right? So this is what I'm going to do. So this is what my thing as well. So what I need going to use right now is I need a server like anything like the server framework that basically wraps up your API and do that. That's what I'm going to use now. I'm going to use a framework called as echo .new. Okay, so I'm just going to use a v4 version of this. This is the latest version. Okay, So like everything you do in Maven or anything, I'm just doing an analogy with Java because like a lot of people are Java developers. So in Golang, we basically do it using what is called as mod tidy, right? So go mod, if I say go mod tidy, it's basically going to download all these modules, which are nothing but set of other Go files, like how jars are downloaded, and makes my IntelliSense work on my stuff, all right? So this is the first thing I'm doing. The second one I'm going to do is I'm going to create a request. So since it's going to be a test case, I'm going to use the HTTP test package dot new request. So this is going to be a mock request. It's going to be HTTP dot method get. That's what I'm going to use for our demo. And the path is going to be slash. I'm going to pass a query with the root thing. I'm going to pass a name, and obviously the language which I missed want this to be translated. So it's going to be in Tamil. So and then I'm just going to pass a nil. I'm not going to be anybody. So what this basically does, it's passing two query parameters. If you remember here on my struct, I'm just going to get it parsed using this thing. We'll bind it soon via the framework. I'm just going to pass a language and I'm going to pass a name. So it's going to translate that into the respective language and give it to you. And this language, this is like BCP 47 language codes. If you just go Google BCP 47, you know what are those language codes, where do you want to get it translated, all right? So once I do this, let me make this a little bit more bigger or cleaner here. The next thing is like I'm going to get the response. It's again going to be a recorder. I'm going to say HTTP test and then say new recorder. That's the one. And finally, I'm going to create a context from where I'm going to send this stuff up. Right? I'm just going to say new context, and then I'm going to pass my request and pass a response. So this is what I'm going to get the stuff out. All right. So when you do this, let's start asserting the stuff. That's what I'm going to do right now. Assert dot no error. I'm going to define a method called as greet. This method is not still there, so we're going to define it soon. And then if there is no error, then start doing stuff. Since I imported another new package here, so you see a lot of things out here. Let's go to go mod tidy for them so that everything is up here. Okay. So this is nothing but just like a JUnit to do all assertions based on your thing, right? The very first thing what I'm going to do assert, I need to write this method as well. So let's go here to the class and then a function greet. I'm going to take the context, go dot context, and it's going to return error in case anything happens. That obviously returns error code back to your function, right? And for now, I'm going to fill it up with return nil, and we'll come back to this in a second. So that's what I'm going to do right now. I'm going to say greet, and then I need to pass the test thing here. No error. If everything goes well, then I'm going to do this. What's next I need to do? The second thing I'm going to test is assert dot equal, just matching my HTTP error code. I'm going to return 200 if all goes well, and then the response is going to hold the code as well. That's what I'm doing here. The third thing I'm going to do again a check for an error where I'm going to do a unmarshalling of my response from a stream into JSON. I'm just going to do JSON dot unmarshal, and then I'm going to pass the data that is going to come from response dot bytes. Okay, and then I'm going to give what I got. Okay, so let's go here. Define this stuff where got equal to, sorry, is again going to be greetings. That's what I'm going to do here. So I'm just going to did that, and then here it's going to pass this one. All right. So I'm just kind of passing the pointer to that, and that's it. And finally, I need to say I'm just going to copy paste the code just to save some typing for me. I'm just going to say equal the want dot message is equal to got dot message, and that's pretty much our simple test case for this method. So let's do a go mod tidy once more so that all the modules are there. Okay, I think somewhere the co has imported the version 2 of this. Okay, we're all good. So if I just need to copy a couple of things from there, I just need to copy dot env. So I have a bunch of variables. One of the variables is the API key that I have. I'll show you how to get your API key from the Google Cloud Console at the end of the session. But just imagine this is my API key that I'm going to use. I put that as an environment variable here. So if I go do test, obviously the test is going to fail for us now because I've not implemented the actual logic to kind of go translate the stuff, right? So you say here, but I'm not getting here, I'm getting an empty response, right? Okay, let's go implement that. So let's make this one bigger. Okay, I'm going to minimize this one for a second. The very first thing I'm going to do is c.bind, and then I'm going to give a greeting, an interface here. So what is this greeting interface? Is nothing but greetings. Okay. So what this will do, this will basically take the greeting structure, parse your request, and then wherever we are giving this query, it gets bound into this particular structured value, right? That's what it's going to do. So I just say it also returns you an error. So I'm just going to say an error equal to, and if error is not equal to null, I'm not going to do anything. I'm just going to return it back. Okay. So what if all goes well? So one thing I need to know right now is, so we need to give a target language to translate, right? Where you want to translate, get it translated. So that's what I'm going to do. I'm going to call it as TL, and this is also going to return me an error. I'm going to get it from this. So a language is a package. I'm going to say parse, and then I'm going to say g.lang, right? So I wanted to convert the string into a particular language code. That's what I'm doing here. Once I do this, obviously there could be an error. So when something goes wrong, I'm going to say error fatal. It's going to come out, and then I'm going to build this message also, fmt.s printer. So this is all standard C++ kind of thing. Hello, and then say %s. And it's going to say the name from it. Okay, these are all pretty simple, straightforward thing that I'm doing here. So once I did with this, so what I'm going to do is I'm going to call the client. So client is what is becomes very important. Now I'm going to start playing with the Google API now. So there's a translation SDK there. So Google Translate. I think, let me see if I got the cloud one. Yeah, that's the one. Translate.new new client. Okay, obviously I have to go back and do some more, go more tidy. All right, so this one is here, and it takes two things. It takes a context, so it's a request context kind of stuff. We'll instantiate that in a second, and then option I'm going to give dot with API key. If you remember that I have the environment variable, the API key, I'm going to take it from that as well. That's what I'm going to do a second. So ctx timeout. So this is going to be 10-second timeout. If I'm not able to do anything within 10 seconds, it's going to error out. And I'm going to get the API key from my environment variable os.getEnv API key. Okay, that's it. So once we are done with this, so I'm just going to say again the same thing, error fatal. Okay, in any case something happens here. Otherwise, I'm going to get a response and again an error, and then start doing with the translate client dot translate. Okay, and then I'm going to say go mount ID once more, make sure everything comes out here. Okay, all good, I guess here. So translate, and then it's going to take three things, again a context. So anything within 10 seconds, I'm not going to respond from an API, I'm going to fail. The second one is an array of input. If you know we are passing the message, that's what I formatted here. Let me bring this here for more context. Okay, and then I'm going to pass a string which is going to say hello plus your name. And the last option is I'm going to use a target language which you also got, and then I'm going to say translate dot options. I need to say which source language, so we are going to use English here, dot English, and then the format is going to be text. Okay, you can also do an HTML translation as well, but we're not doing that here. We're just going to do a text translation, right? Once, so since we are sending an array for translation, we'll get back an array. So that's what I'm checking right now to make sure that we get something back. Else, I'm going to return error fmt dot error unable to translate. Okay. So okay, I'm just going to take this out. Okay, I'm just going to say the message here so that it says okay. All right. So we're good here. So let's go back to our class. I'm sorry, I accidentally closed that one. So the same thing here. In this, something is going to happen here. I'm going to make sure that I return the error back. Else g.message is going to take this one translation here. I'm going to get a response. Since it's an array, I'm going to take the text out of that. Okay, and then return c.json. The framework gives you a framework kind of thing like a method to return this back. http dot status. Okay, that's what you have put on a test case, comma g. Okay, and this is the dead code, so we remove this out, and we are now done with that. So if I just go back to this code, I'm getting the language, passing that into language code so that I get BCP47 code here, and then I'm creating a context. The context is something where we can pass information to the API, and then I'm also pulling the API key from my environment variable that I'm going to use to call the Google Translate API, and then I'm doing a translation, instantiating a client, and then doing a translate using this particular method. Let me break this down for easier reading. So I'm using a translation language, the message, and then what kind of post language on. There's also a method in Google Translation API which can also do auto deduction of your text, which can also be used, but in this case I'm not using that. I'm going to go straight for that, right? So what you need to do right now, let me hit the tidy again so that everything is good, and then if I say go test, this should pass right now as per my thing, if all goes well. Okay, there we go, our test passed, and then we went to the server, got this thing translated into this. Let's take something else. Let me put for them, if I say in Kannada, this should fail, right? Because we are expecting this, but the thing got translated in Kannada, right? So it's kind of playing with that stuff right now. So you can use any BCP translation code you want to do for this, right? So this, what we have done right now is that in like say matter of like 15 minutes or so, we made an API and we call the API, and I use Golang because the reason it's very simple to get the thing done. The next thing which you want to see as per in everyday's developer's life, right? Let's shift back to my code, right? I mean my slides. So we did this code. So this is what we do every day, right? The next thing what you're going to do right now every day on a cloud native developer, right? Everybody is in cloud today, right? What we do is like we take this application, do Docker build, and then Docker push to a registry and Docker run. So this is going to be your everyday command, right? In this case, if you see the app which we build right now, I containerize using a Docker file and push into any cloud, or even you run it by yourself. So this is going to be the task that everybody runs every day in a cloud native world, right? Even the simplest of API what you're doing right now. But the problem starts here, right? Because since we said it's cloud native and you're doing a cloud native developer, you're going to go for a distributed computing, which means that your application is going to be spread, hundreds and thousands of services spread across multiple different clouds, right? And every time you do this, right, I have to do a Docker build, Docker push, and then Docker run, Docker build, Docker push, Docker run, right? It's going to create a lot of complexity, right? Because you also need to do other things like you have to make the service expose your ports, run on the same VM, take care of compute, lots of other problems comes, right? What I actually term them as operational complexity, right? When I kind of do this kind of work, what happens is that I land into scalability problems because there's going to be thousands of services that you need to run. And I cannot apply these kind of deployment techniques, right? I want to do a rolling update, canary deployment, blue-green, you name it, right? And rollbacks, etc., right? So because microservice is always fast, I need to have a faster feedback on whatever I do. That's exactly what it's done, right? In short, if I put it, your release lifecycle becomes super complex and hard to manage if you have something just like this. Just do Docker build, Docker push, and Docker run. So the solution was partially solved by Kubernetes with Docker, right? Because Kubernetes was taking care of orchestration of your containers. All I have to do is like build the image, push it into a registry, then Kubernetes can pull this out and start running this thing for you, right? Which it takes care of all these hard tasks of running, orchestrating, doing all the stuff was solved by Kubernetes for you. But still there's one big problem that needs to be solved, because when we talk about microservices, it's all about speed. At what faster rate I can deploy my application into production, how quickly I can roll out, how I can apply the latest deployment techniques like canary or other stuff to make sure that I have a constant feedback from my customer and saying what he has to do. So to solve the problem, you have to land on something like what we call here on a CI/CD, right? So what happens right now is, you see two developers like us, like what we coded right now, I'm going to push this image into GitHub or get any kind of Git repository. and there's going to be a build pipeline that's going to be run. I'm going to use Harness CI pipeline and see how we can use that. And then the build is going to build and push the image into the registry, into the container registry, which means that you don't need to run Docker build and Docker push by yourself. All you have to know is like, I know to write program, I know to write application, I write my application and push it into the registry. And this is my pipelines is going to take care of pushing it into the container registry. In our example, what you're going to see right now, we'll push the image into Google application registry. All right. And once it is there, it becomes easy for Kubernetes to kind of pull. There are multiple techniques that we are going to. One of the techniques we are going to see later is GitOps. So how to use GitOps to kind of apply this manifest so that my application is running in Kubernetes. Okay, so all the language that a developer has to learn from now on is just going to do, write your program, push it into Git. After that, everything is going to be taken care by your CI/CD and GitOps pipelines. All right. So let's do that. So I'm going to leave this for your offline read, and let's do CI, and then I'll come back to that if you have questions. So let's go back to my code. I have to do a bunch of things. This in interest of time. I'm going to copy a few things here. I'm also going to copy some config. I'll come back to this config in a second, but good. So what I'm going to do right now, anything within that harness folder, yeah, please. You can control for this demo, I'll be doing any push to the main, but technically you can control with tags or any kind of branches or anything. What is your strategy, you can control with any strategy you want to do. Right? In this case, since it's a demo, I want to show it quickly. I'm going to be doing only for just on push. Okay. Great. So this application is done, and I also wanted to introduce another, maybe like another project, maybe later. So if you see this, I don't have any Docker files here, but this application is going to be converted using an image, using a little project called as Go Containers co.build. If you go to co.build, I have all the links on the resources thing. Probably like you don't need to worry about that. What this code does is a little utility that takes your Go program and converts that into OCI compliant image, right? Which is nothing but your container image end of the day, right? So which makes easy for that. I don't need to write a Docker file. I know to do end of the day, build my binary, put it inside a particular static container, distro-less containers if you have heard of, and then push it to the registry. All right. So before we import this pipeline, so anything within this harness folder within your source code can be imported into your pipelines into harness. I'm going to show, that's what I'm going to show right now. Let me see if I still have my session up running here. Let me go to refresh. All right. And then I'll import this and explain this. So I have a template here. Let me go and open this here. Is it clear at the behind? Okay. So while the build runs, build takes 2 minutes to run. I'll come back and explain all of the resources that we have right now here. So for now, just imagine that the resources are in the Harness CI pipeline is split across account, organization, and on project level. So we can have a kind of various level of access control on your pipelines and its resources. Resources basically here is nothing but set of connectors. For example, I have one connector that is connecting to my GKE cluster here, right? Similarly, when you click on this, I have cloud providers. I can connect to any cloud providers I want. I can connect to artifact repositories if I want to push my artifact into a repository. And I can connect to any number of code repositories, predominantly Git repositories, which you can connect to monitoring and logging systems from your CI/CD pipeline to kind of do this stuff, and lots of secret managers. This is very important stuff that we always do. It can, by default, it comes with the default secret manager. If you see here, it's used Google KMS. But in case if you want to bring HashiCorp Vault or AWS secret managers or any other custom secret manager, you can definitely bring it, right? So, and secrets, as I told you, I'm storing one secret here, the Google application credentials that's going to use to call the API. You can use any number of credentials you want, the variables you want to use. And there's another interesting concept here is what's called as delegate. What it basically does, Harness platform is basically a SaaS-based platform. In many cases, what happens is that as a customer, you want to run something within your premises, right? You have a confidential code or some deployment is not exposed to the outside world. I want to go deployment from my pipeline into this particular environment. In that case, what we can do is like we run a delegate within your data center, and then what Harness API basically do is sends a trigger to the delegate, and then that starts running the build within your data center. It's not going to run on the cloud. Even in another case, you don't want to use any of the cloud, you just want to use manage or draw the pipelines on the cloud and everything to be taken care within your environment, then that could also be done. So that's what delegate does. It's a simple utility that runs within your application, within your data center, right? So I have a delegate right now. This runs within my Kubernetes cluster so that it understands the namespaces and other stuff within there to kind of go do the deployment. The another interesting thing which we have used in this demo is templates, right? Obviously, the name says what it does, right? So, because let's say if I have a Go program or even a Java program, I do a Maven build, Maven test, and then jar or var or whatever we do, and then push it, right? So, this is going to be the standard step that we are going to follow. What we can do with this here is like we can just kind of write this as templates. If you see here, I'm going to download some binaries. So, if you open this up, this is a bunch of scripts that I'm writing here, doing some curl commands, downloading the credential, Docker credential helper here, and then the core binary which I said, and then into this particular thing, and I'm going to do a build. Okay, this is the very first step that I'm doing here. The second step I'm doing as part of my pipeline is build and push. This is where I'm going to build and push this particular image into the container registry. Okay, and you also see there is a bunch of exports that I'm doing here: image repo, image tag, image tn, image digest. I'm going to say that what I'm going to do that I can export this as what we call as output variables. So basically what it basically does is that the next steps can take the value from that and start using within that particular step. Okay. So and then I need to pass a couple of other things. app.dar is where you have to start building the code from, and then the Docker repo where you want to push the image to. Okay. This can also be done. Everything is done here. And the last step is build the manifest. I'll come back to that, but the idea is that I make a manifest, the Kubernetes manifest as an image again and push it into the registry. So this is one of the recommended techniques of late for GitOps, because if you heard about, how many of you heard about Salsa, secure builds? Okay, Salsa builds becomes very important right now because the C page of your security or CVEs start right from your code, right? So what this Salsa standards tell you is like at what level of securities your builds are there, the artifacts that you are producing out of the builds. Okay, so we got what is called as a container signing, where you can basically sign your containers, like how do you generate checksums for your binaries, right? You can sign your containers, and then once you deploy it, you can verify if your container is signed by the signature which you used to produce that particular stuff. And you can also trace back how the build was done, what all the commands was done, etc., etc. So the idea of here is that building a manifest that way, what happens is that I can sign, and this becomes immutable, which means that it can be tagged and SSH digest attached to it, so that you cannot apply anything. There's no middleman attack. So one of the common mistakes we do when doing containers is that we kind of take latest. Okay, always get latest. We don't use a tag or we don't use a SHA digest or anything. In that way, what happens? There could be somebody in between, an attacker, who can just say that image and then give you its own translation, right? We don't do any checks also. So the container signing becomes very important. So I've placed some links on the resources where you can read about these container signing as well. So coming back to the templates, so this is what I do. I'm going to repeat this process every time. So that's the reason why I put it as a template right now. All right. So let's go import a pipeline here. So before to do that, what I have to do is I have to initialize this project. I'm just going to do git init. Okay, and say git add dot, and I'm going to say the first message. I'm going to say repo init or something. Okay, and then I'm going to push that into GitHub. Okay, I'm going to call this as translation demo. Okay, that's where it's going to go. I'll go copy this and push it into public repository. This is going to push these things right out there. Let's open that up on GitHub here. So that's the one which we wrote right now. I just push that in Git, and then what I can go back to my harness pipeline, and I say import from Git. And if you see here, I have one pipeline here. I'm just going to give this name like this: build and push. I'll edit. I'll keep all my thing in lowercase. Build and push here, and then I'm going to use a Git selector here. GitHub, you can use GitHub, GitLab, Bitbucket, anything you want. The same connectors which I showed for GKE, you can also define a connector for every Git repository patterns, right? And just say apply selected. So this is going to be list me the repositories here. So I'm going to copy this repository name for this is where we did this. Let's say copy. Come back here and say paste, add this one here. Naturally, it loads the path from here, and when it's do import, the pipeline is going to be imported. So if you see this pipeline is leveraging on the template. If you see here, when I say open that open template on a new tab, this is nothing but what I just explained to you, right? The same template that we saw right now with execution, right? Download, build, and push, right? So it is so easy like this. That's all I need to do this one. And again, if you see the thing, right, and let me shift to the YAML mode. You can also do visual and YAML, but just for explanation purpose, you see there is a lot of inputs here, right? Because this was a template that I created, right? Because the input, the parameters of the template might change when you actually run the build, correct? So that's the reason what we have done here is that we have added a input kind of thing, which is called inputs in the thing. It's an expression, basically that harness CI can understand. And when you pass an input set to it, we'll create an input set in a second. It's going to do the job for us. Like it's exactly the same thing what I told you, but it's a visual editor. If you're a YAML lover, you can just do YAML. This editor also has implicit support, so which means that you don't need to remember the complete YAML here. So in harness CI, everything is YAML, right? There's no scripting language associated with that. So this is what we do. Let's go back here and go to input set, and I can do the same thing. Since I have the input set, I'm going to import this particular input set. I have one thing for GitLab and one for GitHub. I'll share this solution repo also at the end of this thing. It's already there. I'm just going to say GitHub defaults. I'll go find this particular file within your harness folder here. And I've given something, right? I've given a connector. I'll show that in a visually. I'm going to import this one right here. And when I open this up, so it's going to fill up the template parameters for you, right? In this case, I'm going to use GitHub translation demo as a source code where I pushed my code into. Use a GKE cluster for this, and I'm going to use a harness builder, which is a service account that I'm going to use within GKE. I'm going to have a registry list. This is Asia Southern Docker.package, which is nothing but your repository here, your repository on GAR, Google Artifact Registry. That's what I did here. So let me go back, and then what I did, the app dir. So whenever harness clones your source, by default it puts in this particular folder /harness within your container where the source code is available for you. And finally, you'll come back to this again, but again the same parameters where I have to push the OCA manifest images, etc., etc. All right. And I also use a translator service account, GCP service account to call the API. Okay. So this is what is a input set is all about. And then lastly, what you do for the pipelines, right? You always have a trigger for your pipeline. I'm just going to add a new trigger here. I'm just going to say GitHub, and this is basically going to say on push. I call this as on push, and then I'm going to use the same connector here, and then event is on push, and the repository name. I'm going to copy the repository name that I already have here. Translation demo. And about any previous execution, you can have this enabled or done. And this is where things get interesting, right? When the trigger runs, what happens is that the trigger needs input, right? Because I'm using a template, because there are a lot of expressions that needs to be resolved before I actually go and execute this particular pipeline, right? So for that, I can go select the inputs here and then say the GitHub defaults thing which we imported just a back, and just say apply. So every time the trigger runs, this is a parameter that is going to pass to the build pipeline, right? That's what this actually means. Okay, so we had a pipeline which is using a template. We have some inputs because things are going to change dynamically. So we use inputs there, and then we are going to attach an input that's going to be used here, right? And then say create a trigger. So this trigger is going to run on every push. All right. So let's do one build. So I don't have any image right here on my demos thing, or even there is no manifest here. As well, I'll come back and explain the manifest in a second. So let's go back here and then say git commit hello empty. I'm saying build my app. Okay. So you just remember the SHA here, D29 D3CB. Just remember that for a second. And it's going to say git push origin main. All right. And that's so easy as that. Right now, you should start to see the build pipeline getting triggered. Let's refresh this for a second, and you should see something got activated here. Okay. The internet is playing. Okay, we see this one. This got activated 17 seconds. I'll come back to your question in a second. So let's see here. If you go to the execution history, the first pipeline has started right now, and if you see this here, D29 D3CB, that's the commit hash that we did here. You remember here, the same commit hash that we pushed here is trigger a build for us, and this is going to run through the pipeline. It's going to take a couple of minutes, cloning code base, building image, and pushing that into GA. Yes, sir. Yes, we can put all those things. We can put all those checks as well. So again, you can put the checks even at Kubernetes level as well, because if you use policy controllers at Kubernetes, like we can even put that check saying like I cannot deploy this particular image between this version range. Right? We can also put this. I'm not showing any manual thing is here. Whatever I'm showing that is completely automated. We can also induce any kind of manual approval steps in between in case if you want to stop your pipeline, do that stuff and go away. Right? So that's what we're doing right now. Download the binaries. It's going to download that and start running this. So let's give some time for that. So while we do that, what I'm also going to show you that about the deployment, right? So how many of you have done Kubernetes deployments here? Quite a few. Okay. So what I'm going to use here is again a Kubernetes deployment, and I'm going to use what is called as customize. And again, I'm sorry if people like, if you're not used to Kubernetes, it's nothing but the way how do you write manifest again YAML and deploy application to Kubernetes, right? So that's what I'm going to do right now. I'm just using this particular image from mine. So if you see here, I have a bunch of YAMLs. So what with customization I can do is like I can kind of reuse my existing deployments. So I don't need to write this deployment, service YAML, service account, service, etc., etc. every time I wrote this, because only my image is going to change. So that's what I do with customize. With customize, I basically say pass this image, whatever image I'm using in my original deployment, with this particular image that I'm going to pass as part of my build process. Okay, where did I get this from? If you go here, let me go to my pipeline here. Let's go to AD pipeline. The better is the template, because that's where I have this. Okay, I'm just going to shift to the YAML thing. So if you see this one at the end of the thing, the application image tag, application image digest, these are the replacements that I'm basically doing in my customization. If you see here, the environment variables, so they are basically taken from the previous step outputs. So if you remember here, the previous commands, when you do the build, I'm putting the image repo, image tag, image digest, everything I'm getting exporting from one step. I can pull that particular image value, the value from that particular build, because every time I do a build, there will be a shard get generated and a tag gets attached and the image gets pushed to a different path. So everything is available for me through these environment variables, and I simply do this environment variable substitution here, so that this customer same manifest gets applied, but with a different set of parameters. All right. So every time you do a new build, that's going to be applied. Okay. Let's go here and see what happened to our build. I think we should have successfully done a build. Oh my God, it says it failed. Let me see what happened. It's failed to build. Let me see if I can. Okay, I see the problem right now. Can anybody guess the problem? That's going to be super goody for you if you can guess my problem. Yeah, that's the reason. The image is not got published. That's true. So tell me this error. What does it mean? It's okay. I'll make it big. I don't want from Hanesians like anybody else. Tell me what mistake we have done. I've done a grave mistake here. Okay. Sorry. No. I give you a clue. Something is here. Public static void main. If you're a Java developer, right? So I'm building a server here, right? The server has to start and server has to run. I totally missed that step here. I did not have a main function from where I'm starting the server. So what basically when I do an image, the image looks for the main function that needs to run so that it can compile that and push that binary in. Okay. That's what I'm going to do here. It's going to be pretty much simple thing that I'm going to write. I'm just going to do the echo new, the same thing we did earlier. New, and then I'm going to say e dot logger fatal start colon 8080. That's what I'm going to do. I'm going to use a couple of middlewares here, so don't worry about this. E dot and that's middleware. That's called recover. Okay, that's what I'm going to do here. It's going to be v4 middleware. Okay. I'm just going to do go more tidy, and then say let's run the server once to make sure it's running. All right, and then if I go to my command line and say http, I'm going to run the same command as our test case. Okay, what happened to this right now? Is there an error here? Okay, oh, b.get slash, and then I'm going to pass it to the greet method which you already have. Okay, and that's it. So when I do this one, go server again and just go to do this. This time it should pass. I should get the response back. All right. So now with these kind of changes, now if you see the when you do the pipelines, we can just start doing these kind of changes again and again, right? You don't need to kind of do any kind of Docker build, Docker push. Fix. I just going to call add main. That's what I'm going to do. I'm going to push into GitHub. Sorry, and we should see another one starting soon here. Okay, that's going to be pipelines. Let's go back here. Go to build it here. Let's say refresh this once more. Yeah, you have one more started. This time it should build and push successfulully. Let's wait for that. So this is one of the convenience that we get when we kind of start using CI/CD, because we are able to do build and push in a fraction of seconds, right? So if you imagine for a second, in the last 15 minutes, we have written an application, written a pipeline, hooked it up with your delivery setup kind of thing, right? So all I have to start continue doing is that continually evolve my application, iteratively increment it, publish it, and then deploy that into anything and make it available for people to use it. So that's all it requires, right? So this is advantage when you start to use these technologies like build and push, CI/CD and all of that stuff to make application available for you quickly, right? This is, I'm just saying an example for this particular application. This could be similar use cases that you'll be using within your organization where traditional ways of doing stuff was not helping, right? A lot of people came to our booth. They will also ask me a question. Okay, we are using Jenkins. What's the difference between Jenkins and Harness here? What's the big difference I get? Okay. So one of the common problems that we always did when you start writing CI/CD, we started to call this CI/CD, right? So it was okay when you start to write, but the problem is, right, once you write a CI, okay, let's say take the same case, I want to deploy my application into Kubernetes, right? Let's say GKE. So what my CI pipeline will do, my CI pipeline, now you go and add a step which says like deploy to GKE, right? Now I come back, okay, I acquire another company. The company has everything in EKS, right? For example, Amazon Kubernetes cluster. Now what I do, I go back to my pipeline again and start writing the deploy to EKS, right? And now your pipeline starts, the CI pipeline starts to grow a lot, right? We are trying to mix infrastructure within a code. Technically, what CI has to do is just build your application, your source code, convert that into an artifact. In this case, convert that into an image, right? It should not do anything more than that, okay? And also, second thing, if you see from a security point of view, right? Who access CI? Mostly developers, right? Who access CDs? Mostly ops guys, right? Now, what basically happens when you start to mix these things together, right? We're unnecessarily exposing these kind of credentials, the operation production credentials to developers, right? That's going to be a severe compliance issue if you are in financial industry, because you should not supposed to do that, correct? So, and then again, the complexity, as I told earlier, you are mixing your infrastructure with code, right? So that's also another issue like which you're not supposed to do within CD. So what is the solution for that, right? So you successfully done the build. The build is done. That was one mistake we did. So I was just talking about this one, right? So we did CI. We talked about these pain points just now. How hard to maintain because your script starts going. You're mixing CI and CD together. So the solution for this is GitOps. What is GitOps, right? So for example, in you saw right now, I did not do any big fuss here, right? So let's do. So in this case, what happens? I don't have a deployment done yet. I'm going to do that in a second. But the whole idea is that, as I said earlier in the start of my talk, for us, the central thing that we are going to use even for CI or even for CD is going to be Git. Git is going to be my source of truth. Whatever is deployed, whatever tag or whatever branch that you decide upon your deployment strategy, what you deploy into production, that's going to stay as truth, right? Let's say my production cluster comes down for any reason, okay, some natural disaster or something like that, then I have everything within Git, so I can just replicate that in another thing, in another cluster or something like that. In this case, I kind of mix. I also show that in last I used Terraform here to spin up my GKE cluster, and that also has a concept of notification, like how we configure the trigger, right? I can send a notification once the infrastructure is ready, start populating everything up. I'll just show a small sample in the end of this session. So what GitOps basically means is still doing continuous deployment, but we are going to version the deployments. Every deployment is going to have a version so that it's easy for you to go to rollback, deploy more faster. You're going to do deployments within another 15 minutes time that we have right now. Okay, so an easy recovery and fast recovery as well, because when you want to roll back, all you have to do is go back to a previous tag and apply it again. It's going to apply. Easy credential management. In this case, I'm not going to use any credentials here. Okay, so it's going to be have one centralized. You're not exposing unnecessarily the credentials to the developers. You keep it to where it needs to be. Only authorized person knows that. Self-documenting deployments. What does mean by this is that the artifact that we produce, for example, I showed you a customization file, correct? So that file is a manifest file that is used to deploy to Kubernetes. So that itself is a document, right? I know what I'm deploying, which image I'm using, what versions, what environment variables I'm using. Everything is documented within that, right? Again, finally, the entire team within your organization, the complete team, what we totally call them as DevOps team, right? It's 2-pizza team or whatever we call it. Every team basically talks the same language. I know to write Java program, I know to write Golang program, I know to write Rust, but all I have to do is like commit the code into Git. That's all. After that, my environment, my CI and GitOps is going to take care to take it into production. Okay, so one part we already did here because we just went ahead. The second part is what we are going to do right now is I'm going to do a commit and push again, and then the code is going to go use Flux and Argo's cloud native CNCF based projects that use GitOps principles inside Kubernetes. That's going to reconcile every time. It keeps checking your Git repository for changes or versions or tags, that probably the strategy that you use, and then do the deployment for that. All right. So in this case, we are going to do a main based. Everything get pushed into your main or latest thing that's going to be deployed. Okay. Let's do that. Before that, we'll go check what we have already here. So this is one repository where I'm going to push stuff here. Hopefully it's not kicked me out. It's taking some time. All right, go to demos here. So the translation one just got pushed 3 minutes before. This is a container image of our application. And then if you go back to our stuff again, there's one more thing I have some manifest. That's a customization bundled into a image again that got pushed again here. Okay. So we are going to use Flux here. So what basically happened, if you check one of my pipelines here in my project, I have a bootstrap thing here. So I use Terraform Cloud, basically, if you heard of Terraform Cloud, to kind of provision my GKE cluster. Once that is done, there is one of the features that Terraform Cloud has is called as notifications. Okay, I trigger a notification, Flux Bootstrap Harness CI, that uses webhooks, like how Git commit pushes triggers a pipeline. It does the same way. And once this is done, what this basically kicks in this particular pipeline here, the Bootstrap pipeline. It basically going to go install components into my Kubernetes cluster. This is just an example of here, but you could have various examples like this where you want to have something triggered after your infrastructure provisioning and take it into CI pipeline. This is one of the complex issues when you kind of use CI/CD, is that how do I make my infrastructure, which is usually is infrastructure as code like Chef, Puppet, Ansible, or you name it, right, Terraform, and make them talk with my CI pipelines, because I want something to be warmed up within my container, some software components to be installed and used, right? So this is one of the ways by which you can do this. You can use triggers, webhooks to kind of take this stuff and deploy it there. Okay, so I just bootstrap the stuff right now. So what I'm going to do, I'm going to use Flux here to do a bit of thing. I'm just interest of time, instead of me typing this, I'm just going to run a bunch of commands. The very first command I'm going to run is to create the translation OCI repository. OCI stands for Open Content Initiative, the image that we actually pushed into GAR, right? I'm going to use the same image here and then do a reconciliation. If you remember, when you saw my slides, I said we use what is called as reconciliation. So it always keeps checking for the latest. If you see this one, this has a SHA-87819, right? Let's go. Let's check it here. Go to image manifest. Click on this translation image. And you see this 878194. That's a manifest that got applied here, right? So it's going to pulling that image down for you and doing it. Okay, this is a one-time activity that I'm doing because we need to configure our GitOps stuff here. I'll tell you how this works sweetly after the change that I'm going to introduce in a second. Okay. So this is going to do again same kind of a reconciliation. Again, it's going to use that OCI repository to kind of do the job for us. Okay, that's what it's going to do right now. And then if I go back to my Kubernetes cluster and then say kgsvc, let's wait for the. So you still need to wait because GCP takes some time to get a load balancer IP. So we're going to wait for a few seconds. So now what I've done basically is that I pushed the OCI image. Everything is there in Git for me right now. I connected my deployment with my repository. That's what I did here. Like GitOps is one of those principles where few things we need to do once and then it starts to take the thing, right? The other one, what you also interest here is I'm creating this thing and then the interval that I'm giving here is how frequently I need to check. Okay, so since it's a demo, I'm just putting 1 minute, but in real production, usually we'll not put in 1 minute because the controller keeps running, keep checking your repository for 1 minute. In some cases, if you run out of API limits as well. Okay, and the second one is same thing. I'm just going to use and then I'm going to say deploy this particular OCI repository manifest and translation demo. I'm not running any kind of kubectl commands here. I'm not even running even one single kubectl command here, but I got my application already deployed. Okay, even the services got right now. Let's say, let's check the service. I think this is not at all interested after this. I want to pull this up, give more space. Okay, get the service from this. Okay, having this particular service, you got the external IP. So let me go grab this IP for my usage. All right. And then I'm going to say open this. I'm going to run the same thing again if all goes well. Okay. I have one single extra tick here, so that's not working on my. Okay, there we go. It's the exact same application that we deployed locally. We have pushed. And we have not written one single infrastructure line that I have done. I just initiated the GitOps thing to make sure that everything comes from GitOps. Shall we go and prove another push again? So what I'm going to do right now, I'm going to take this out here and then go back to my code and then say instead of hello, I say thank you. Okay. That's what I'm going to do, and then I'm going to do commit and push update greeting. I'll just add a couple of more stuff here. I'm not going to update my test case just for interest of time. Okay, just going to update this one and push it back here. Sync the changes. That's all I need to do. This is what, as a developer, I know. And the moment I do all this stuff, what is going to happen is, if you go back to my pipelines again, there should be one more pipeline got triggered here, execution history. There we go. The other pipeline got executed right now, and then you see this one. Let's see, once you initialize the code base, we should see the commit message that we gave right now. Let's give it a few seconds. I think it takes 2 minutes approximately. You see, update greeting. This is the commit message that I gave. That's what is getting updated right now. Let me see this. This is much easier to see. Okay. So let it do the build. And what we also are going to do is, I'm going to go to my command line and do this neat one. Okay. Flux get customizations dash watch. Okay. So it should say like we already have one thing deployed. They should update with one more thing that after this committed build and push is done. Okay. So let's wait for that to happen. So while it happens, probably if you want to try harness platform, you can just scan this QR code. We have a free tier that's kind of gives you how many credits if I'm not wrong, 2000 credits or something. Yeah, 2000 credits, and then you have a limited build option. Some enterprise features are restricted. You can give a try with that as well, or if you can visit our booth, which is right opposite to the main hall. We'll be happy to talk and discuss about stuff. And after that, the other important thing that I have is I have left over with lots of resources at the end of these slides. So whatever things we discussed right now, if you want to read more, try more, once you get the slides, you have an access to this. And one of the important stuff that we did as part of this session is what is called as workload identity. So in Google Cloud or any cloud for that matter, if you see in our example, I have not used any kind of credentials across there. So I basically did everything to be done across GKE, right? What I have done is that I've tied the service account, Google service account with Kubernetes service account, and it inherits the permissions from the Google service account. So that's a concept called as workload identity. I've written a blog a few weeks ago about that. There are 3 blogs there. You can just go read about it and see the power of it. It's a keyless ways to include the Google API stuff. Okay, and the demo sources. There's a translation demo solution is where you find this entire source code that I built right now. I'll be pushing that there. You can just grab a copy of that as well there. All right. You have done the build. It's going to do a build and push here right now. We have pushed the manifest as well. Everything is done. Let's go and see. The translation is also synced up right now for you automatically, just doing git push and other stuff. Let's go and refresh this one to see what we got. Let's say it takes some time for the translation. There we go. So the message got changed. Whatever is done from here, Git 2023. There is some nasty translation that Google Translate has done it. I'm sorry about that. So end of the day, like the message is like now we have Git as one source of truth, right? Everything what we do is at Git at Git. Okay. So what I really recommend you to go try this stuff out. Reach out to me on my social handles. I'm available on Twitter, LinkedIn, and GitHub if you want. And I'm also writing articles on dev.to. In case if you want to follow me there, you can follow me there as well. On all the articles that I'm talked about, I'll be keep writing on those things as well. And thank you all. Thank you so much.